chamo. We some about algebraic expression part 2. So today we see on part 1. Now part 1 was about variables. That means introduction to algebraic expressions. Into you have variables, you have coefficient, you have terms, and then you make a cake home. So you can go back. And then we see what the algebraic expressions part 2. Into a part 2, the idea we see more about maybe they say like terms and unlike terms. After the best how to do operations on algebraic expressions. The other so how do algebraic expressions are bend then Bruce Ben they are the Bruce Ben is subtracting a home run is saying how do you multiply algebraic expressions? Indeed, way any ambition. Into other room, Michelle, modern pay attention. So the bear wants to beat me at in ye be swan was good. Indeed, me can credit there be swan like terms and unlike terms. You can say like terms then like terms, HSL terms, they have the same variable and I say same powers. Indeed, examples are no be Anna ye one. So we share 3x and 5x only now the same variable as x. After only now some the same power. Nti then you kasa ni nti a the kasa no say so over 3x is one term and a 5x is another term. X is raised to the power 1 and this x is raised to the power 1. This is the same variable. There how many x high x now power near 118. If it's make say only like terms. The channel so they are like terms because they have the same variable x and have the same power 1. So both x. So very. Now I didn't think I say the power near 1. The say a channel so say oh if it is x the power is always raised to 1. So x no can try a raised to the power 1. And not exponent 1. If we have y, it is exponent 1, but I am sure. The channel so. And I sense you as a coefficient of x and a 1. Good. Sana symmetry. And the another example is 2y squared and 7y squared. Bring down y squared. The same variable, and the powers are also the same. That is the reason why a bit marker said that's an intimate bit marker said like terms. Now we have 4x and negative 3xy. So I have 4x and negative 3xy. I don't so bring now xy. At the international like terms and what's and for addition and subtraction of algebraic expressions, say oh like terms I'll bet me add. That's all like terms, so I'll bet me subtracting. This is example here we had 3x plus 5x. We are like terms. It says only the same variable when you know our x. It means me a coefficients number. Coefficients near 3 and a 5. So 3 plus 5 am 8. Then you take one of the x. So you have 8x. If you see what DP, how to add them. Now so we one more who need here like terms down here. After yen twice then go on like terms. The opposite for like terms and unlike terms. Let's just say variables need different and a powers need different. When it's all 3x and 5y, you say variables need different, a higher x and a higher y. So for another second example, 2x and 3x squared, you say powers need different. We have power near 1 and a way getting a2. It means say a bad thing. Say on bet me a couple and on bet my subtract. Say ocean 4xy and 4x say, and also different variables. So yeah, first one at you. So we have xy here. We have 4x here. Into 8 mean boom, and I say 8 mean subtracting. And into that, so here example, how I say 3x plus 5y. I be the same as 3x plus 5y. They cannot combine. As I said, different variables. They are unlike terms. They say a friend saying unlike terms. Nice. Today, the answer to see who said if your algebraic expression, not the variable near the same, that's the power is near the same one. They can say like terms. But say, oh, algebraic expression, not power is near different. And now say variables near different. The maker said they are unlike terms. Good. I think there will be showing you a friend types of terms. Nti that your brand new extra terms, you say what expression to say s squared, it is one term. What you say? You can have an algebraic expression to say x squared plus 2x plus 4. We are one term, we are two term, we are three term. Into this whole thing, one algebraic expression. Now, so algebraic expression be to say we are this s squared, ɔfrɛ no monomial. This one say a term baako pɛ. This is a monomial. A term baako pɛ monomial. And here are examples of some of the monomials. 5x is a monomial. Minus 3y squared is a monomial. 7 is a monomial. And 2xy is a monomial. This is what you see. Now, so two terms this way, we're friend of binomial. It's example, maybe a x plus 5, because your x and your 5 to two terms. Way a term 1, way a term 2. Your 3a minus 2b, this is term 1, and this is term 2. If we have x squared plus y, in general, so like I said, we have term 1, and so like I said, we have term 2. What was next here? So these are called binomials, binomial expressions. We have two terms. Now, what's a trinomial? We just say what you say, try from the word three, the three terms. This is one term, this is two term, and this is the third term. Good. And we have another one, 2a minus 3b plus 5c. It's also a trinomial. And x squared plus 5x plus 6 is also a trinomial. Indeed, sir, monomial, binomial, and trinomial, I can't watch them. Say, what term more than one, it will collective name be a friend of polynomial. So this, it do a binomial, but which one can say a polynomial? It's a polynomial. And this, is a polynomial. So x cubed plus 2x squared minus x plus 5, I have 4 terms. And it is a polynomial. Do specific name my friend here trinomial, that's an also a polynomial. As I said, it has an expression for one and more terms. This is x plus one and more binomial specific name. But if we have binomial, trinomial, 4 terms, in a friend of polynomials. Good. Into polynomial. I think my end also with operations on algebraic expressions. Then I done here when operations here plus, minus, division, and multiplications. Into your convention with me, add it. With me, I can algebraic expressions are boom. Convention with my subtracting. Convention with my dividing. Convention with me, I'm multiplying. Michelle, do you need and also net year? Rent fee. And here started from addition. So all kind of algebraic expressions are boom. Convention here no. And here when I say algebraic expression x plus 2 and I all come 2x squared plus x plus 1. Many saying. Yes, so what has to say, now so Now catch and say first thing I said you try expressions no. What you say? I see a try expressions no back or backwards. In the one say what x plus 2. We are adding with 2x plus 4. So you do x plus 2. We are try back on so we not say, right? You try say. You group like terms together. You can say we are like and like x and x, same variable. Use your numbers. The overall x plus 2x plus 2 plus 4. Your group like terms. After we know variables now. As I said, you added the coefficient of the like terms. The coefficient, no, a higher 1, right? So you're going to have 1 plus 2, right? Plus this one, 6. With 1 plus 2, 3 x and plus 6. What I said. It's not say near baby Edry, online terms in T. If it is because 3x plus 6, we need to mean come on. We a variable. We that's just a constant. You cannot do anything to it. They are online terms, so we leave it like that. Good. Into a rule for addition. Then solve examples of addition. Into the first question, they say add, that's we are adding 3x plus 5 and 2x plus 3. So here 3x plus 5 again. First one is a better write the expressions. The back of back was 3x plus 5 plus 2x plus 3. Good. And we group the like terms. This and this are like terms. 3x and 2x are like terms. So we group them together. And 5 and 3 are constant, they are like terms. We add a coefficient. If you're adding the coefficient, that's an you can kind of 3 plus 2, right? We are going to have 3 plus 2 and x here, then plus 8, 5 plus 3 is 8. So we're going to have 5x plus 8. Indeed, that becomes the answer. So good. Okay, the next example, yeah, 2x plus 3y plus 5, and then 4x minus y plus 1. So convention we write the expressions under each other. 2x plus 3y plus 5. We group the like terms. It will say 2x and 4x are like terms. They have the same variable. Now the same variable. 3y, any 2y's, I'm your like terms. Now we say constant. So if I come up with the share on bracket 2x adding 4x plus 3y. We have the sign here to be minus. To be minus 2y plus 5 plus 1. In this one, we add a coefficient. This all here 2x plus 4x. The baby 2 plus 4 bracket x. And normal 6x. We share 3y minus 2y. We add a coefficient, which is 3 minus 2 and y. So you're going to have what? Y. The bare one y, but you can say y. What is it? Then 5 plus 1, number is 6. In the combining number, my baby now 6x plus y plus 6. And no, I never had. Good. So the answer is 6x plus 6. 6x plus y plus 6. Sure. Did you say what you are seeing? After the subtraction. Say, who person will subtraction so and also the same to say any addition at now so do baby and not subtract your who minus will be na confuse you because we subtraction with that. And don't think on a say a share of foundation or say to subtract algebraic expression first need to write down the expression one below the other. Then you can't write some down. And the second one I said change the signs of all terms in the second expression. Then group like terms together and add the coefficients of like terms. The happy and I saw association and 3 change the signs of all terms in the second expression. Good. Indeed, the Ben is saying, combining examples to be named here. Indeed, also subtract 5x plus 7 from 8x plus 10. Into a 5x plus 7 if we 8x plus 10. What I say? Indeed, who is BBF BB more? Let us say, I know one son, I'll go to BBF. Into then, all that 8x plus 10. Now then, the 5x plus 7. Into a metro 8x plus 10 of first. Right? 8x plus 10 of first. And son, I bet you this is subtract. So yeah, this is subtract. Yeah, subtracting the whole of 5x plus 7 if we maintain the special bracket. 5x plus 7. Right. And I'll say the first thing, the next thing is to change the signs for the second. Right? In the yes, change signs. So 8x plus 10 is the first expression. Second one, it is assumed to higher 1 to minus 1 and multiply 5 1. We begin minus 5, right? Now the s na count plus minus, sorry. The minus because minus 1 times 7. So minus you multiply 7 now one day no s minus will be affected too. So we get 8x plus 10 minus 5x minus 7. See, now we are in one. You might be group like terms. Into a bus step 3, so group like terms. Into like terms near then 8x minus 5x plus into bracket 10 minus 7. Good. Into 8 minus 5 minus 3. Then we have our x. This is going to be plus goes 10 minus 7. So 37 from 10 1. We got 3. So the answer is 3s plus 3. Nice. After the shares all question been up and you write under the comment. Say okay, we want to say let's share in the next video. So that is it. Now let's move on to the example 2. We are subtracting 3a minus 2b plus 5 from 7a plus 4b minus 3. General bending. Send a D can you know. We have way and I ordered that. Way there. Yeah, way there. I'll say subtract 3a minus 2 plus 4, 5. Nti kwa 2f wo. That's we know what I ordered that and you get 2f. To a boss 7a plus 4b minus 3 a boss. What I say? And I yet subtract into brackets 3a minus 2b plus 5 left frame. So 3a minus 2b plus 5 left frame. What you saying? Next thing is we have to change the sign for the second expression. You need to assign this is said this is here. It doesn't say a minus 1. So the minus 1 and multiply we have minus 3a. So minus no s and multiply another minus a be positive. So be plus 2b minus and multiply positive. So you can you know. Now how are so minus 1 times positive 5. Minus 5. Nti afọ ya by being 7a plus 4b minus 3. And only a first expression I ordered down. And I have minus 3a plus 2b minus 5. After you by you don't need a bracket because you are grouping like terms. 7a and 3a they have the same variable. So we're going to have 7a minus 3a, right? Plus 4b plus 2b plus minus 3 minus 5. It was 7a minus 3b, 4a plus we by my 6b. And I had by my minus 3 minus 5. My minus 8. 2 they come in, some they come 5, they come 1, they come up with 8. So we get y plus 6b minus 8. Is I say, you do maybe a on like terms into me now. We are 4a, we are 6b, we are constant. So I need to do into that becomes our answer. So our answer becomes 4a plus 6b minus 8. Seria una per Afei, we subtraction. Our can be multiplication of algebraic expressions. To have a multiply. Then so multiply Edina is using monomial, trinomial. Some for only be bit me up by me multiplications, as in name. So the can grant say we are going to multiply monomial by monomial. The can say monomial to say 5x is just one term, it's a monomial. And to say we multiply 5x. Now we are multiplying 5x, right? By another 4x. So we have 5x times 4x. Convention or multiply. Or say multiply the coefficients and multiply the variables. And the coefficient of 5x, 5, right? And the coefficient of 4x is 4. So you multiply the coefficient 5 times 4. 5 times 4, 5 times 4, 20. Then you multiply the variables. So the variables near s and x. So x times x give us s squared. Adding here is an x. I will multiply. You add the exponent. It is assumed here x raised to the power 1 times x raised to the power 1. It's going to be x. You better add the top one. Then you get s squared. And our final answer, you combine them by 20 s squared, because you know that this gives us 20, this is s squared. You have 20 s squared. After you have more example, you have more examples of multiplications. So an example is multiply 3s by 4y. In this AD can you multiply the coefficients, the coefficient 3 and 4, 12. You multiply the variables x and y, you combine, you get 12xy. The answer, yeah, 12xy. So the answer is 12xy. And example 2, 2a times 5a. The same thing. Multiply coefficient 2 times 5 is as 10. Then you multiply the variables. 10 can we have a times a, is raised to the power 1, 1. So you're going to have a 1 plus 1. You add the exponent, a squared. You combine, you're going to have 10a squared. The answer is 10a squared. After, we are going to multiply minus 3x squared times 4x cubed. Until you multiply the coefficients, minus 3 times minus 4. That gives us minus 12. You multiply the variables, you add the powers. To reach s squared times s cubed. So s squared times s cubed. So you can you have x here? You have 2 plus 3, because you're going to add them here. That gives us s raised to the power 5. Get s raised to the power 5. We combine them, we have 12, we have s raised to the power 5. So we're going to have, oh, sorry, we have minus 12 here. So we're going to minus 12, s raised to the power 5. That's the answer. Good. In doing that, anything cry. Now, who's saying how to multiply binomial, monomial by monomial. Now, say, what person will multiply monomial by binomial way. Then you come here. And you said this is a odds. This is a monomial. Because a one term a pay. But this is a binomial because a b plus c 2 terms. Good. So if you are multiplying a monomial by a binomial, you might be a friend of distributive property. So this expression a into bracket b plus c mine A, B plus AC, it's called distributive property. Okan ben so no. So you can this monomial I multiply this binomial. So A into bracket B plus C. A no be multiply B, in one bracket A times B, right? Plus in another bracket A times C. Into A times B, A plus A times C, AC. So now we know that the expression A into bracket B plus C equal to AB plus AC. Good. Now let's solve some of the examples, distributive property examples. So we have 3x multiplying 2x plus 5. Maybe can kind of, it's going to be the same as you multiply this. So you're going to have this multiplying and adding this. So 3x times 2, never mind, 6x squared. No, you know you are multiplying. 2 multiply the coefficients. So yeah, express what really can kind. You're going to have 3x times 2x plus 3x times 5. We multiplying. Good. That's how multiplying. And yeah, and then 3x times 2, remember 3 times 2, remember 6. And that x times x, remember x squared, because in the same way you reach the power, and as some multiplier, you add the exponent, so you're going to have squared plus 3x times 5. You just multiply the coefficient to give you 15, right? 15, then you attach the x. So the answer will be 6x squared plus 15x. Good. Now, Okan bench need to multiply binomial by binomial. Also multiply binomial by binomial. Your format be a bit by use. Emma only confused the brain. My friend of FOIL method. FOIL. The FOIL. Good. Into FOIL, no? Then it's right. The FOIL is an acronym. F needs the homa first. And that O needs the homa outside. I need the homa in a L needs the homa last. Then it's right. So if we have binomial x plus 5, and it is multiplying x plus 6, we are going to use this to actually understand how we can multiply binomials x plus 5, which can multiply x plus 6. But this is a binomial 2 times. It's also another binomial. Now let's move on. So the first method, not just say, you have to first multiply the first into when they first, and first, right? So you are going to multiply x times x into s times s, remember s squared, because you know say it's exponent 1 here, exponent 1 here, higher 1. This is 1, this is 1. They add, it gives us s squared. Now the other one say, how you have to multiply the outer. The outer near then. This is at the out. Hanum. So far on the whole expression out in here, and see out in here. So multiply x by 2. So you're gonna have 2x. After that, you have to multiply the inners of all the expressions. The inner of the expression, first binomial 3, and this one is x. Yeah, the inner ones, right? Cool. So you're going to have 3 times x. That gives us 3x. And the last is multiply the last by last. This is the last, and this is the last. So then you have 3 times 2. It gives us 6. If we are combining, so you have x squared plus 2x plus 3x plus 6. If you have x squared plus 2x plus 3x plus 6. But here we can simplify this because these are like terms. We have the same variable. So 2x plus 3x will give us 5x. So we're going to have x squared plus 5x plus 6. D is another nice. Okay. So the answer gives us x squared plus 5 plus 6. Now, yeah, division of algebraic expressions. So we divide the algebraic expressions and then now the when you send the away multiplication, I say on the powers, what you do is to add the powers. In division of algebraic expressions, we subtract the powers and divide the coefficients. So you divide the numbers now. How do you do that? Example, they say divide 12x by 3. Into 12, into first thing, so you are going to divide the coefficient. 12 divided by 3, that will make 4, right? Then we keep the variable, which is x. We combine, we bring 4x. They're very simple. So the answer is 4x. Now, if you have to divide 15x squared, 15x squared divided by 5x. How do you do that? So you're going to have 15 divided by 5, right? 15 divided by 5, and 3. Plus 5, acquire 1, then goes here 3. There's a 5 times, I never made 15. Say 3. Good. Now we have x squared divided by x. Say you can also here we are. We're trying to say x squared, right? Divided by x, where you write one of the x, then you subtract the exponent into higher way 1. So you subtract, you get 2 minus 1, and x, which is the power 1. And then if x raised the power 1 is the same as x. So now our answer, 15 divided by 5 is 3, and x squared divided by x, which is the same as x squared with this sign x, and x. We combine them, you're going to have 3x. Sending 1. Nice. Good. So the answer is 3x. Now, another one I say, when you calculate 24x cubed y squared divided by 6xy. 24, you divide 6. Let's just say it's the same as 24 over 6. 6 equal 24 more 4. Just say, now I better add multiply 6 multiply by 24, and that is 4, right? 6 times 4 is 24. So we get 4. And the x cubed divided by x, same kind, you take one of this variable, which is x, then you subtract the exponent. Yes, subtract the exponent because we are doing division. So 3 minus 1, right? That gives us x squared. And you get x squared here. For y squared divided by y, you're going to have 2 minus 1 here. And that will be y raised to the power 1, which don't write because the same as y, right? Good. So you're going to, so we now have 4 on your x squared and y. So you combine it, and that gives us 4x squared y. That's what the answer is. Good. Halfway. Yeah, we is in here. See, addition, subtraction, multiplication, and division. How do we simplify algebraic expressions? Brian, no. Yeah, we say we have been, simplify algebraic expressions. Yeah, my form simplify so my expression. Tintin tonight it one. Now say rule. That's why I know you be a. And the first one is say your parenthesis. Yeah, I can use brackets now. We can use distributive property. Now if you are combining like terms and arrange the terms in order, usually descending powers. Then let's see. When you simplify the expression 3x plus 2x minus 5 plus 4. In this expression, on the ability, you better identify like terms. To identify like, these are the like terms. Because we ignore variables, the same variable, same power. These are constants. Good. So you have 3x, 2x, and minus 5 and 4. Yeah, if we are combining like terms, so 3x plus 2x, we combine them, and minus 4 plus 4, we combine them. 3x plus 2x will give us 5x, and minus 5 plus 4 What they can 5? I could try 4. Over sound they come back. So you get 5x minus 1. Good. Do exactly 3x plus 2x minus 4, 5 plus 4. You simplify in the crowd, my other than 5x minus 1. 7 billion. After your 2x, 2 into bracket x plus 3 plus 3 into bracket x minus 2. Then you remove the parentheses by multiplying this 2 by x, right? Then solve 2 into bracket x plus 3 plus 3 into bracket x minus 2. So we multiply 2 by x, we need 2x, right? Plus 2 times 3, minus 6, plus 3 times x, minus 3x, minus 3 times 2, minus 6. After we have to group the like terms. 2x and 3x, we come up with 2x plus 3x. The one plus I is 6 minus 6. The 2x plus 3x by my 5x plus 6 minus 6. Oh, the cast is good. Just I only can be literally 0. So the answer will be 5x and I will. That's actually another one. Simplify 4a minus 2b plus 3a plus 5b. Then also we big group of items 4a and 3a items. So the question bracket back on minus 2b and a positive 5b. They are the same items. They have the same variables, right? And minus 7 are a constant and also a different variable. So you combine here 4a plus 3a, but 7a, and you draw minus 2b plus 5. What the cat 2 could you have 5 Akan sister, and then 3 na Akan. Then you attach the b, which is the variable, minus this 7. So the answer becomes 7a plus 3b minus 7. Then is here. So combining is here from last time now. They say terms are separated by plus or minus. But no correct. 2 or x squared plus 4x they are separated by plus. It with my minus and so x squared minus what? 4x. They are separated. Alternative. Good. The entire gas a plus or minus necessary. So multiplies is here. It not be a term again. Because we have x squared times 4x based on the history. The Bible 4x cubed. It's a 4 no higher 1. 1 by multiply 4 and you 4. X near squared. And I weigh 1. You know say multiplication. You wait to multiply no. The multiplier it will pick 1. Then you add the exponent into a higher raised the power 1. And the 2 plus the 1 will make 4x cubed. And you see what we see trust say terms are separated by x or minus signs in algebraic expression. Now you see like terms again. Like terms have the same variables, the same powers. So 2x and 14x. Okay, I find the 14x. They are like terms. That's almost the same powers. Power is 1. Power is 1. The same variables x and x, right? 2y and 4y are like terms. Good. We have x squared and 3s squared. They are like terms, but they have the same power. So, good. Now, and I need to send you on like terms. So if we have 3x, y, and 4x, y squared, they are not what like terms, but the powers are different, right? Next thing is coefficients are the numbers multiplying variables. Yes. And so if we have a variable term like this, 4x, it means 4 is multiplying x, and this is the coefficient. But before is a coefficient, and x is a variable for a letter. Now, constants are terms that variables. True. the x squared plus 4. This is a constant. 4 is a constant, has no variable. When adding or subtracting, combine only terms. So when adding or subtracting, combine only like terms. So if you have x squared plus 4x plus 3x, we anyway into me more. This cannot end me for encourage more. What I say. But with me account 4x and 3x are both. So they are like terms. So we're going to have x squared plus 7x. Good. Nice. But say, yeah, if you are adding, that's it, and I say subtract here. Let's say, we say 7x squared plus xy. And to me, either. Into answer number 7x squared plus xy, right? So I'm a person say subtract here, I will the same answer because they are unlike terms. Then be na sign at was so the sixth rule they say when multiply coefficients and add powers. For multiplication, if you be able to my name of rule they say oh multiply the coefficients and add the powers. And you are adding the powers when they are the same, they have the same they have the same variable. And the say so xy times xy, right? It's the higher one. So yeah, we don't with 1 times 1 is 1. But x times x by x squared. So we're going to have x squared. And 1 times y by y squared because we are adding the power. So x will add x, y will also add its power, right? So get x squared, y squared. Good. Now when divide coefficients and subtract powers. In the division, so yeah, you have to, so 124 divided by 6, right? You are going to have 4. Send the end of the and here one example where you have an algebraic expression that is dividing. So if we have 24 x squared y divided by 6x y, what do we do? 24 divided by 6, 4. X squared divided by x, x squared divided by x, in x, adding here, because you take one of the x and you subtract the exponent, 2 minus 1, right? You're going to have x raised to the power the same as x. Now you have y and this y. Y divided by y will give us 1, adding here, because this is raised to the power 1 into. You take one of the y, and you have 1 minus 1, because they say a linear exponent, 1, 1. And we are going to get y raised to the power 0. And they can say everything raised to the power 0 is what? 1. Right? So now if we have 24x squared y divided by 6xy, you can say 24 divided by 4, my 4. And now x squared divided by x by x, we are combining. And this is 1. So the answer is 4x. Because times 1, we multiply 4x by 1, same as 4x. And the answer number 4x. Great. And yeah, assign you say always simplify expressions by combining like terms. X squared plus 4x plus 8x plus 3 minus 2. Yeah, simplify, yeah. First thing, you have to make sure say big group like terms. Where your like terms, 4x plus 8x, right? Plus 3 minus 2. You have x squared plus 4x plus 8x by 9. 12x plus 3 minus 2 by 1. So this is our final answer. And the final answer is to say, yeah, we need into me coming doing more. Yeah, online terms. And this is the simplification. And Anna, a dear addition about it too. So, all questions be a Daruma, na, oh, my smarting. You just write another comment. And I say comment also say once subscribe, you cannot write a comment. So subscribe so that you can add your comment and I'll reply them. Or I address them on next video. Good. Then you be for see the algebraic expressions about me. Therefore, then you be you do more practice exercise for algebraic expressions. They say we know when I say yeah and come. Don't worry. In our next video, it will be more of practice exercise for algebraic expressions. Indeed, thank you very much for your attention. Please like and subscribe. Thank you.